Chapter 5 Torsion Part A Example 4 Drive shafts in rotation and power transmission. As you can see in this figure, you can observe a rear axle of a vehicle connected to rear differential, and the rear differential itself connected to drive shaft. This is the drive shafts which connect the two axle rear and front. We do have rear axle, rear differential connected to driving shaft which connects the two axles, front differential, as well as front axle, and finally engine. You can easily see a combination of gears in rotation, mhm, which included a lot of these small parts, connects the rear axle to driving shaft and transmit the power in a vehicle. In our example, a drive shaft's AB in a vehicle, in an automobile, is to be designed by a thin valve tube. The engine delivers 150 horsepower when the shaft rotates by a 1500 revolve per minute. That's the angular velocity. Determine the minimum thickness of shaft's fall if the outer diameter is 2.5 inches. The acceptable or allowable shear stress is tau shown by tau allowable and is 7 ksi. So to approach the problem, first of all, power is torsion times torsional torque times the angular velocity. Let's have a brief review on both units SI and both British unit. Again, power is torsional torque times angular velocity. In SI, uh, power, the units for power, torsional torque, and angular velocities are in power is in the unit of watt, torsional torque is Newton meter, and angular velocity is in radian per seconds. Likewise, in British unit, power goes by foot pound per seconds, foot-pound per second, torsion is pound-feet, and angular velocity is radian per second in both of them. 1 watt or each watt is 1 Newton meter over seconds, and 1 horsepower is equal to 746 Newton meter over seconds. 1 horsepower in British unit is 550 pound-feet over seconds. By knowing this, we can attempt our problem. So again, power is torsional torque times angular velocity. By converting our angular velocity 1500 revolve per minute, each minute is 60 seconds and each revolve is 2 pi radian. By doing the math, it gives you a angular velocity of 157.08 in terms of radian per seconds. Replacing that in our power formula, power is provided, W is calculated. The only unknown here is torsional torque. So converting 150 horsepower to a pound-feet per second, which is multiplication by 550, gives you a torsional torque times angular velocity, which is replaced from the only unknown here is T, and it's going by having a torsional torque of 525.21 pound-feet. As soon as you know the torsional torque based on torsion formula, tau allowable is, which is provided to 7 ksi, is equal to Tc over polar moment of inertia. We got the torsional torque, but just let's convert that. Let's convert the C in 125. Uh, uh, so torsional torque is uh, 525 pound per feet. Let's convert that feet to inch. Let's uh, that's the 12.4 times the outer radius for the shaft itself, which is the diameter was 2.5 inch. It goes by 125 inches over polar moment of inertia, and the only unknown for this part is C1, inner radius. If you do that, do the math, it gives you C1 is equal to almost 114 inches. And the thickness of the shaft, the thickness of the driving shaft is the subtraction of outer and inner radius, and that gives you a thickness of 0.104 inches.